Now let's look at another example, example 4, which has multiple start activities and multiple end activities. We are again presented with this information to enable us draw our network diagram. We shall proceed to sketch the diagram. Once we are comfortable, we would present it formally in our network, precedent network diagram. Now, activity A, B, and C are all starting activities. So we would write them down, A, B, and C. Now, A precedes activity B, and B and C precedes activity E. D precedes activity F, and D and E precedes activity G. So we have the relationship indicated. Now activity F and G precedes activity H. So we have a relationship there, and we have activity I preceded by G and activity J preceded by F. So this is how our diagram will look like, and with our precedence diagramming method notation, we shall proceed and draw our network diagram following the sketch we have drawn here. So we have activity A, B, and C, D, E, F, G, H, I, J, so as indicated. And we'll draw the linkages. So the next thing to do is to write the duration of the activities. So A is 3, B is 5, C is 3, D is 6, E is 7, F is 4, G is 5, H is 7, I is 3, and J is 4. We shall then proceed and have our forward pass calculated. And we start with activity A. So 0 plus 3 is 3. Activity B, 0 plus 5 is 5. Activity C, 0 plus 3 is 3. Now for D, 3 acts as the early start for activity B. So we have that and have 9 as its early finish. And that of E would have 5 being its early start and 12 being its early finish. For activity F, we have 9 going as its early start and 13 as its early finish. For activity G, we'll pick the highest, which is 12, going as its early start and 17 being its early finish. For activity H, we pick the highest, which is 17, going as its early start and 24 being its early finish. And we do that for I, 17 going to I and 20 being its early finish. And for J, 13 goes, 13 plus 4, 17. Now the last activity to be completed will be H with an early finish of 24. So it means J will get completed by 17, I will get completed by 20, but H will be completed by 24. So when doing the backward pass, you pick the highest, which is the last activity that was completed, which is 24. So we repeat 24 for all the ending activities, which is j, h, and I. So for j, 24 minus 4 is 20. For h, 24 minus 7 is 17. And for I, 24 minus 3 is 21. Now, when conducting a backward pass, the list always goes to the preceding activity. So for activity F and activity G, we will have 17, and 17 minus 5 is 12, and then 17 minus 4 is 13. Now for activity B and E, we'll have the list going, so 12 will go to D and 12 will go to E. And 12 minus 6 will be 6, and 12 minus 7 will be 5. Now for activities A, B, and C, we will have the list going. For A, it will be 6, for B and C will be 5 and 5. So 5 for activity C minus 3 is 2, 5 for activity B minus 5 is 0, and 6 for activity A minus 3 is 3. So we have finished with the backward pass. What is left now is to have our floats and then also determine the critical path. The critical path can be determined when we conclude on our floats. So the float is either the late start minus early start or late finish minus early finish. So we'll do that. So for activity A, it is 3. For activity B, it's 0. For activity C, it is 2. For activity D, it is 3. For activity E, it's 0. For activity F, it is 9. For activity G, it's 0. For activity H, it's 0. For activity I, it is 4. And lastly, for activity J, it's 7. So we can identify the path with 0 floats B, E, G, and H. So the critical path is path with 0 floats and also longest path through a network. The longest path because the last activity to be completed was completed on day 24. So it is the longest path. So our critical path will be indicated or is indicated in the red arrow as shown above.